Hello, everyone, and welcome to the webinar, Putting Sustainable Manufacturing into Practice. My name is Mike Holman. I'm a SVP here at Lux and moderating this session today, which was presented by my colleague Anthony Schiavo, Senior Director and Principal Analyst, who's been thinking a lot about these issues around manufacturing, what it means to make it sustainable, and really what it means from a strategy standpoint and to strategic and innovation standpoint in order to put that into practice. So looking forward to the presentation today and to the discussion. We'll have time for questions afterwards. So anytime during the webinar, you can type your questions into the question box on the screen. We'll answer as many as we can at the end, but if your question doesn't get answered or you think of a good one afterwards, don't hesitate to email questions@luxresearchinc.com and we will respond. So with that, I will hand things over to Anthony and jump into the presentation.
Thanks, Mike. And I'm happy that I'm able to present here today on sustainable manufacturing. I want to start with this, Y2K. I think everyone of a certain age probably remembers those stickers that were put on everything. It's remembered as a flop, but really it was a successful transition. We spent billions of dollars and companies were very proactive about avoiding the issues of Y2K. So it was really a very successful transition in that sense. And it's the kind of thing that we want to repeat, of course, with sustainability. So for two key questions here: how can we transition to transformative approaches in manufacturing? And how do we bring the sustainable transition to every business, right? How do we make the transition to sustainability as successful as the transition, from the Y2K era was? So one way that's obviously very important is policy. You can have very aggressive policy in the US. We already see some of this with the IRA, but I want to put this aside for now. The reason being that I think it's important to accelerate this transition as quickly as possible. And we need to do that even in regions and in businesses that don't have strong supporting policy. So I want to focus on business models today and how we can really use business models to accelerate this sustainable transition. So with that, we'll look at 3D printing. And then we'll apply some of those lessons, those business model lessons from 3D printing to sustainable manufacturing. And then we will just share a few thoughts on where we see things going and how I see the future sort of unfolding here. First question, why 3D printing, right? This is a little bit far afield from sustainability. Well, it's a big growing market, right? And it has a number of important applications, everything from oil and gas, to dental, to aerospace. And what I want to emphasize is that it's really a very, very transformative technology. It's a completely different way of manufacturing these products than the past approaches. So it's the most recent and in a lot of ways the most successful case study we have of a truly transformative approach being adopted. That's why I think it's good to look at it for our sustainability approach. So we're going to consider this in the context of the flexible manufacturing framework. These are a way of thinking about the value that's brought by flexibility. And 3D printing is a very famously sort of flexible manufacturing technology. You have input and output flexibility in terms of what kind of resources you're consuming, what types of products you're producing. You have timing flexibility, how fast you can make something, how quick you could turn around on something, and your overall sort of lead time. And then you have scale and location flexibility, how much of something you can make and where you can make it. And different technologies have different attributes in terms of these different elements of flexibility. A lot of the examples of 3D printing are very basic, right? You can make something a different shape, right? Or you can make sort of a novel design with 3D printing. I think everyone understands that. But there's a lot of business models in 3D printing that really rely on flexibility outside of those most basic manufacturing or mechanical elements. One good one would be the example of Lincoln Electric. They are leveraging timing flexibility. So they made headlines by printing 8 large refinery parts in just 30 days in response to a supply chain issue with Chevron. Um, they used this advanced 3D printer. This is kind of an electric arc welding style printer that can print these very large parts. But in addition, they were able to really drive, I would say, the timing of this by leveraging a set of custom software and a dedicated support team who are able to take the existing designs of the parts that Chevron needed and translate them into a 3D printable version very, very quickly, right? Within that 30-day time frame. This is typically a significant amount of engineering work and also qualification work necessary to actually get parts to a printable state. Anyone who has worked with 3D printing can tell you, I think, that 3D printers have a tendency to fail and actually be quite finicky in terms of how they actually produce the parts. So this combination of access to this printing technology, but the skills, the team, the software, the business model, surrounding it, really enabled Lincoln to deliver on this, and it saved a huge amount of money for Chevron, right? Um, it prevented the downtime, which is very, very expensive. Now, these parts aren't a one-to-one replacement for the existing parts; they were only a temporary solution, but that still created a ton of value for Chevron in this case. Another example of flexibility is Formlabs, which has really begun to push into dental 3D printing. Formlabs is really notable for its low-cost 3D printers. A comparable stereolithography printer used to cost around $300,000. I think Formlabs sells its printers in the range of $8,000. So there's been really substantial cost reduction, right? Which is obviously a very important part of the story. However, there's a lot going on here other than cost reduction, right? They have made the right kind of materials available for dentists, that are qualified for human contact. But they've also, again, deployed a very wide range of business model approaches. They have custom software that is designed to make the 3D printers easy to use for non-experts. They have a lot of education available to their customers to really help them learn how to use these 3D printers. And they have, they offer kind of a complete service package to their dental customers, providing materials, providing any of the sort of machine management that they need in order to make this really seamless. And the advantage is that it enables Formlabs to bring the manufacturing directly to the site of the dentist. This really shortens the turnaround times. It enables a lot of flexibility. And for Formlabs' perspective, it allows them to serve a much smaller customer, right? A local dentist shop, sort of a family-owned or a small operation, as opposed to merely serving the largest customers. So there's benefits for both sides here. The point I want to make about 3D printing is that we do see that technology competitiveness was important, right? In the Lincoln Electric example, you have Lincoln Electric enabling this new type of 3D printing, right? In the Formlabs example, cost reduction is really important, but that's just the first step to technology adoption. What was really necessary in both cases were supporting skills, business models, and ecosystems. Everything from design to implementation, the material supply, the training necessary to allow these end users to really take advantage of these new technologies that have improved. Okay, so let's apply some of these examples to sustainable manufacturing, right? Again, we're focused on two key questions here. The first, how can we transition to transformative approaches in manufacturing? So something that's really radical, really, really different. And For that question, let's apply the flexible attributes. So, first example, Genomatica has partnered with Unilever to build a flexible supply chain via fermentation. So, Unilever is a significant consumer of palm oil derived surfactants and other palm products, which are increasingly under pressure because the palm supply chain is not viewed as sustainable. There are issues with deforest, deforestation. There are issues with animal welfare, and so the goal of this work is to provide an alternative to these palm oil based products, particularly surfactants. And I think what's really interesting here is that flexibility is really called out as a goal. Um, you know, they're specifically trying to use fermentation because it can potentially take in alternative inputs like sugar and produce these sort of novel, high performing surfactants. But both companies acknowledge that in the long term, the goal is really to build a robust, flexible supply chain that can use a very wide variety of inputs um, and produce a very diverse set of products. And that's what makes this larger scale investment worth it, as opposed to just buying this product in a one-off approach. Secondly, I want to highlight Pangaea, which is a footwear company. They have recently launched this 3D printed shoe with a pretty wide range of sustainability benefits, everything from lower carbon footprint to easier recyclability. The shoe, as you can maybe tell from the image here, is actually made of a mono material. It's a single type of material. And leveraging 3D printing, they're able to modify the density, modify the structure to produce a pretty wide range of different effects, while at the same time still sort of enabling recyclability, because all this can just be put in one waste stream. With 3D printing, the shoes are printed on demand, and they're able to be ready for the customer in just 3 days, despite the fact that they're customized to the shape of the customer's foot. But importantly, for a sustainable product where you're not really sure what the demand is going to be, um, you're not really sure what the supply chain is going to be like, you're not really sure what the end of life stream is going to be like, committing to a significant scale up of production in order to meet the customer demand for easy availability is a really big challenge, right? It would be very expensive and also very risky for Pangaea to produce enough of these shoes to have them ready in 3 days or available at their different stores, their retailers, their online sales, if they were using a conventional method. With 3D printing, however, there's no need to invest in production up front. You have the 3D printers, and then when a shoe is ordered, you print exactly that shoe. So it's this timing flexibility, this ability to wait until an order has come in and still produce the shoe in a really, really timely manner that's enabling Pangaea to experiment with these sustainable business models, right? Or these sustainable products, I should say. So, even though this is still a pretty early stage type of approach, obviously, we're not all walking around wearing 3D printed shoes. The flexibility of this type of technology is really what enables the actual sustainability benefits in this case. And lastly, I want to highlight an example that's often not thought of in terms of flexibility, and that's electrochemical production of ammonia. And this startup in particular, Fuel Positive, is working on fast ramping systems for small scale modular ammonia production. And they're really targeting on site production at farms, where they can consume the ammonia for fertilizer and use locally available energy sources, particularly small scale solar, to actually power this production of ammonia. Now, this is a fast ramping system, right? But it's worth contextualizing that this is fast in the sense of ammonia production. So we're still talking about, ramping up in hours, as opposed to, turning on and off in minutes, right? The goal here is not really to produce ammonia whenever the electricity is cheap. Rather, it's to be able to scale down enough to produce ammonia cost effectively at a very, very local level, right? Um, what's important to consider about this, and I think what Fuel Positive needs to do, is that farmers, right, are farmers. They are not chemists or chemical engineers. So this company, if they want to really install these ammonia production sites on farms, are going to have to develop a lot of supporting tools. They're going to have to develop, you know, whether it's software that manages the actual production of these fuels or excuse me, fertilizers, whether it's a system that really encompasses everything the farmer needs all in that modular container, um, whether it's the services to support those farmers when things inevitably go wrong. All of that business model framework is going to be necessary. Just dropping off a electrochemical ammonia production unit on a farm and saying, "Hey, good luck," is not really a recipe for success. But with this, there's an opportunity, I think, to accelerate our sustainable transition. Right? We can not only move away from the very carbon intensive approaches to ammonia production that are currently in use, but also create a lot more resilience. For farmers, the prices of fertilizer have been a major concern in the last couple of years, especially in Europe. So, locking down that supply chain and having that security is actually a really important element of this technology, in addition to the, of course, sustainability benefits. So what you can see is that sustainability and flexibility, I think they're really linked. Um, these new business models that we've been discussing, whether it's on-site ammonia production or flexible fermentation, they can help these transformative approaches scale, right? And the values and the benefits of flexibility are really crucial to building a value proposition for sustainability. And I really think that every emerging, transformative, sustainable technology provides flexibility because they're an alternative to our existing value chains. And those value chains are under pressure. They might have painful bottlenecks in terms of geography. They might have painful bottlenecks in terms of cost and scale. So any alternative to these existing approaches does provide some degree of flexibility, even with technologies like electrochemical production that aren't really thought of as being inherently flexible or really currently sort of sold on the value of their flexibility today. So I just want to share kind of a few final thoughts and give a few indicators of where this might be heading. I really think that risk and risk management are key value propositions for sustainability. I think everyone has heard this idea of a green premium. People are going to pay more for sustainable products. Um, but it's tough, even in consumer-facing businesses. It's very tough to find a consumer that is willing to pay that green premium. But because sustainable technologies and transformative technologies offer flexibility, they can be used to insulate companies against risks, market risks, other types of risks, particularly climate risk. You see here, I have an image of Hurricane Harvey up on the screen. You know, in America, the production of chemicals is highly concentrated in Houston, and that represents a sort of a geographic and a climate risk. Distributing production away from Houston and away from these areas that are at risk from large amounts of climate disruption, it has value, and it has value that goes above and beyond just the simple cost and economics of the technology itself. So this risk management factor is going to really be crucial in helping companies find a complete value proposition for sustainable technologies. And I think this is important to consider because a lot of companies think about new business models as something that is developed outside of their company, and then they can potentially adopt it. Um, but the reality is that a lot of these sustainable technologies, maybe even most sustainable technologies, are not better in pure economic terms, right? They're not as profitable. They're not as cheap. If they were, we wouldn't be having this discussion, right? People would just be doing them. It would be very easy, but they aren't, right? We often get this question: hey, when are these sustainable approaches going to be cheaper than the alternative? And the answer is maybe never, right? So the combination of these old and new approaches is really crucial. The new transformative sustainable manufacturing routes add value to the old routes, and they add that flexibility. And it's that combination of values, that combination of manufacturing approaches, that is really going to be necessary to actually have these technologies make sense and enable them to reach the scale where maybe they can one day start to be cheaper, right, than their traditional counterparts. But we're never going to get there if we just try and scale these technologies up by themselves, because they'll always be less cost effective than the traditional approaches. So, with that, I'll leave you with a few final thoughts. One, government and big industry are increasingly in a position to address these sort of large scale challenges, but things like policy are only one piece of the puzzle. Um, Technology, becoming more competitive is important, but it's really just the first step. What we've seen with the adoption of 3D printing is that even when the transformative technology has a ton of advantages, you still need novel business models, technical support, software, all these different elements to really make it make sense for the consumer or the customer. And, sustainability and flexibility are inherently linked, right? And that flexibility is really going to be crucial to creating the value proposition for sustainability, especially for industries that don't have, this direct connection to the consumer and aren't going to be able to demand a green premium for their products. And I want to leave you with one final thought, right? Looking at Y2K, big businesses did a really good job. You can see that, General Motors, Exxon, Procter and Gamble, all these big companies were very proactive with their spending, and they were ready for Y2K. Where there were issues with Y2K, where there were problems, it was really with the small businesses, local dentist shops and doctors' offices, other small businesses like that. They were the ones who didn't have the resources to be proactive and actually ran into those issues. And in some cases, it really did harm people. There were issues with medical records being lost and treatments being missed. So, what we need to do in the sustainable transition is make sure that these sustainable manufacturing approaches don't just stay stuck with the largest corporations, and the small and mid-sized manufacturing businesses actually have access to them as well. And that's where business model is going to be so crucial, enabling these smaller companies to really access the sustainable technologies they need to be ready for our sort of decarbonized world. With that, I want to thank you for your time, and we can open it up for, I think, a few questions while we have the time here.
Absolutely, yeah. Thanks, Anthony. We do have some questions coming in, but you can keep typing those into that Q&A box on your screen. And if we don't get to yours on the call, we will get in touch after the webinar. So you've really a few questions here related to this business model innovation, which is as you know, is a topic that resonates with me as well. So I want to go to those first. So one of the things that I think people have seen, particularly in B2B industries, is sometimes that new business models can be slow to gain traction. So I think you make a good case that, business model innovation is necessary to help some of these sustainable technologies add scale. But obviously, the speed is of the essence for these transitions. What do you see as the opportunities to kind of speed up acceptance or adoption of some of these new business models?
Yeah, I think companies often try to launch new business models to their existing client base, and that's a big mistake, right? Um, you really need to be thinking about targeting new sets of clients, whether that's a new geography, a new size, a new industry segment, right? Because probably for your existing clients, your business model works pretty well, right? They wouldn't be your
Yeah.
existing clients if things were really terrible, really flawed, right? So you need to be really trying to expand it to a new subsegment of customers, right? And then from there, once some of your existing customers see the benefits and once it's more scaled up, they can actually come in and start to adopt it, right? And we've seen this with e-commerce approaches where it's really something that started with a much smaller segment of buyers, in terms of size and often different geographies. It's very popular in China, and it's slowly been percolating back to the existing customer base for a lot of B2B, B2B e-commerce, I should say. So, don't target your existing customers, right?
Yeah, you almost have to think of it a bit like, I mean, just as you would with a new product launch, right? You want to think
Hmm.
sometimes of that crossing the chasm model of who are the early adopters, and indeed,
Yeah,
maybe
exactly.
often not your traditional customers.
Typically not your existing customers, I think.
So, um, so we recently had the conclusion of COP28, and there's a
Hmm.
goal there to phase out fossil fuels. So,
Yep.
what role do you see for flexibility in helping that to happen?
Gosh, that's a good question. I do think there's a lot of flexibility here. I mean, one big opportunity is just to match, the types of resources and resource availability that exist in the more sustainable energy sources with manufacturing approaches, right? So, electrochemical approaches, right? Those are lower temperature and don't require like the natural gas or high temperature inputs, right? You don't have to burn typically a fuel to heat them up. So that's the basic thing. But I think a bit more generally speaking, the shift away, if we truly shift away from fossil fuels, it's going to create real geographic shifts, right? We're going to have to physically redistribute our supply chains because, you know,
Yeah.
they're centered in places like the Middle East or, you know, certain parts of America that have access to those resources. So the ability to scale and to operate at smaller scales and go to more distributed resources is really important because a lot of the sustainable resources that are available are more distributed. A good example of this is mechanical recycling, right? Where, you know, we have a lot of plastic. There's this big resource of plastic waste, if you want to think about it that way. But it's fundamentally very differently distributed. It's very localized, it's very dispersed, and it's very expensive to try and centralize in a way that's familiar to the sort of fossil fuel based production. So mechanical recycling, as a distributed as a smaller scale technology, actually enables a lot of flexibility in terms of scale and location to go where the resources are. And I think a lot of other sustainable technologies are like that, where the scale and location flexibility is going to be really crucial.
Mhm. That was an
And
interesting
I
question.
should mention more economical, right? You can access those
Yeah.
resources at a cheaper price point, so it's more competitive. Go ahead.
Yeah, kind of another interesting question related to that is how do you think about, the cases where the sustainable technologies, or it may at least in some ways have less flexibility, right? Like solar power is much less flexible in terms of time than fossil fuels are, right? Because you can't run it 24 hours a day.
Yeah, I mean, I think again, the opportunity here and the biggest value proposition comes from combining the old and the new, right? The non-sustainable with the sustainable, right? And finding these matches. No technology is perfectly sort of sustainable, right? Or flexible, I should say. Um, so, it's really about something like nuclear. That's a technology that is not very flexible, right? Um, and people are trying to make small modular versions of nuclear, but even a small modular nuclear reactor is pretty big and pretty expensive and not that
Yeah.
flexible. But it has a role to play, right, as a replacement for baseload power. So I think that the opportunity is really finding matches between the older technologies and the newer technologies, right? And where can you have something that's either similar in attributes? So nuclear is pretty similar to something like a coal plant where you want to be running it fairly continuously. Um, and you can make a one-to-one swap, or where can you find something that's complementary? Like natural gas peaker plants and intermittent renewables are actually fairly compatible because you can run the natural gas peaker plants when the renewables aren't on. So, looking for one-to-one replacements and looking for sort of, nice compatibilities will be really important. You can think about that in manufacturing terms as well. Um, you know, Ammonia production, electrochemical production of ammonia from electricity and from some other inputs, I think it has a lot of compatibility actually with some of the smaller scale fermentation and chemical approaches as well.
Mm.
Um, just in terms of the location and the scale and flexibility attributes, they share a lot. So you can imagine a whole sort of resource production that's focused on bio-based chemicals, growing the resources, the feedstocks there, and electrochemical production. It's based on electricity, so there are a lot of synergies up and down the manufacturing value chain, not just in energy.
Yeah. Well, great. Yeah, there's a lot more we could dig into here for sure, but I think it's about all the time that we have for today. So thanks, Anthony, for the presentation discussion. Thanks to everybody for joining us. We will send out the slide presentation and recording to all the attendees. But after you leave the webinar, you will get a prompt to fill in a survey about the presentation today. We really appreciate any feedback that you can give us there. We do review those and use that to help us plan more and better webinars in the future. Speaking of the future, we do have a couple of upcoming webinars highlighted here, and always more on the Lux site, or if you follow us on the social channels here. So please check those out, and hope to see you again on those. But thanks again for joining us, and have a great rest of your day.